Expressions, formulae and identities. Now in its most basic form, we use algebra to solve a problem. Now we use letters to symbolise something we don't know or something we wish to find. And we call these letters variables. Now it's convention in algebra not to write a multiplication sign because it looks like an x, and the most common letter we use to represent the unknown is x. So if we wanted to say something like a times b in algebra, we would just write ab. For example, Bert scored X marks in a test. X is representative of something we don't know. Ralph scored 5 more marks than Bert. Write an expression for Ralph's score. So, Bert scored X marks. We don't know how many marks he scored. It could be 20, 30, 55, whatever. Ralph scored 5 more. So let's say it was 55. If Ralph scored 5 more, we'd add on 5 to the 55 and get 60. If Bert had scored 32 marks, Ralph would have scored 37. We'd add on 5. So since Bert scored X marks in the test, to find out Ralph's marks, we just add on 5 to his. So it's X plus 5. It's Bert's marks, X plus 5. Now Sophie scored twice as many marks as Bert. Write an expression for Sophie's score. So if Bert had scored 35 marks, Sophie would have scored twice as many, 235, she'd have scored 70. If Bert had scored 50 marks, Sophie would have scored 100. So whatever Bert's score is, we have to multiply it by 2. So if Bert has got X marks, we need to times that by 2 to get Sophie's mark. Now, we wouldn't really write this in algebra like this. If you multiply a variable, a letter, by a number, the number goes first, so we'd say 2 times x, and following on from the previous page, we don't write the multiplication sign, so it's 2x. Some terminology now. Expressions are a collection of letters and numbers that represent something. Like in the previous example, they were expressions for Ralph's and Sophie's score. Equations, however, can be solved. We can find the value of the letters. For those previous examples, we couldn't work out Bert's score, but if we had something else, if it was equal to something, maybe we could. Identities are always true, no matter what the number the letter represents. This is best demonstrated in the following example. Likewise, for formulae, they are proven rules that can be used to solve a problem. Famous one, E equals mc squared. Okay, so this example, we're going to match up an expression, equation, a formula and an identity. An expression is a collection of numbers and letters that represent something. Well, 3a plus 4b minus c is a collection of letters and numbers that must represent something. It's not equal to anything, so we can't solve it or anything, so this is our expression. An equation can be solved. Now, 4x plus 2 equals 10, we can find out what x is. If we think 4 lots of something, the x plus 2 is 10, some of you might be able to see, well, it's going to be 2, because 4 times 2 is 8, plus 2 is 10. We will look more at this in topic 6 when we look at equations, but for the time being, we just need to recognise that's what an equation is. Formula. So that's a proven rule that always works to find something, and that's d equals s times t. Distance is equal to speed times time. And finally, an identity, b squared equals b times b. Well, that's always true, it's just a different way of writing it. B times b is always b squared, no matter what value b is. So that is an identity.